Good morning, good afternoon, whatever it is in this void that you're sharing with me today. Look, it really is a pleasure to be with you today at NANOG. My name's Jeff Houston. I'm with APNIC, and today I'd like to talk about a very fashionable topic right now, which is actually routing security. I say fashionable because, you know, the old topics are always the best topics, aren't they? And this is a topic that has a good 25-year pedigree. Some problems take a long time to solve because we just never got around to it. We were distracted, taking the dog for a walk, who knows? But some problems take a long time because they're actually really hard problems. And it's not that we sort of weren't smart enough before, but they are just incredibly challenging problems. And one of the biggest problems out there right now, and it's been out there for a long time, is actually trying to figure out how to make the security of the routing system, the thing that holds the internet together, actually resist attempts to subvert it, or perhaps equally importantly, the fat finger problem. Because, you know, in terms of making all kinds of mishaps, we humans are just endlessly creative. So what I'm looking at in this talk is actually how well we're doing in deploying the latest technology offering in trying to secure BGP. Now, the shorthand here, which is in the title, is this is measuring RPKI effectiveness. It's not. It's actually measuring the degree to which routing objects that are invalid according to route object validation, where the validation is performed using RPKI, the degree to which network service providers are performing that filtering. That's a great title, but it wouldn't fit on the screen. So this is the shorthand for an awfully longer title. It's measuring how well we're doing in deploying the elements of routing security. But it's worthwhile, at least to start with, actually thinking about what we're trying to do this time around. Because we've tried all kinds of things. If anyone remembers RPSL, the routing, was it security or routing system policy language? Sure. This, though, we're not quite sure what we're trying to do, are we? Here's a list. If we had to pick one, what are we trying to do? This list gives us a few alternatives. It would be really good if no matter what I type in as config, no matter what my auto config system does, it would be really good if the routing system doesn't have to suffer the consequences. Inadvertent route link, mentioning no names, Telstra, or various other kinds of operational mishaps that occurred over the decades. Or maybe this is armor plating for hostile attack. Maybe what we're trying to do is to detect where the routing protocol itself is being manipulated and false information is being injected. Can we do that for all possible cases? Maybe. Would we like to do it for some cases? Okay, bad people, just do this. You're not allowed to do that because we can't defend against it. Are we trying to prevent the routing of bogus address prefixes? Sort of taking the 10/8 problem, because a lot of bad addresses keep on being announced, whatever a bogus address may be. And what about bogus ASs? There are still a large number of ISPs scattered around the world who think that they too want to be AS1 or 2 or 3, because, you know. What about synthetic routes? Routes that aren't manipulated, they're just pure fiction. And I suppose the hardest, what about unauthorized route withdrawal? I learned this route from you, meh. And the last one, what about protecting users? Because all those first set of things are actually all about the routing system. Maybe the whole object of this is to actually stop users being directed along bogus paths to the bad place. So if we're going to pick one, just one. Before I get there though, perhaps let's shatter the illusion that we can solve every problem on this planet. We can't. And certainly we can't even solve the problems in BGP, because BGP actually has two sets of rules that it has to obey. It's got to be protocol-wise accurate. I get these route objects from my BGP neighbors. I do processing. I send route objects to my neighbors. We propagate. Protocol-wise, the relationship between what I get and what I send is tightly defined by BGP, the protocol. But equally, there's another set of rules, the policy rules. I will not announce my transit learned routes to other transits. Now, the protocol says that's fine. The policy says, Jeff, you're being an idiot. Don't go there. So I've got to be both protocol-wise accurate and policy-wise accurate. And in some ways, meeting both of those goals is actually really, really hard. Side note, the problem is actually in the protocol as much as in the degree of difficulty of the problem itself, because BGP isn't a deterministic protocol. It's a negotiation. You have some export policies, I have some import policies. When they differ, we try and work out what an agreeable kind of compromise is. And the solution that BGP works out is often different to the next time we try it. So sometimes we get outcomes that aren't what we expect. If you want to read some more about that, RFC 4264 BGP wedgies, an amusing read if nothing else. Back to where I was at the touch of realism. So route object validation, which is what we're going to talk about today, is actually designed to prevent BGP speakers from learning and preferring routes that aren't authorized by the prefix holder, not by your neighboring network, not by any other network, by the holder of the prefix. So this is actually address rules rather than topology rules. So the intent of not preferring these unauthorized routes that aren't authorized by the prefix holder, is actually all about the user, not steering the user down bad paths to the bad place. So if we had a choice, well, what's my choice? Protecting the users. Because all the rest is steps to an end, not the end. The end is trying to make sure that your users, my users, well, there's only me, your users aren't directed to places that are synthetic, that are evil, that are designed to, leak information, misdirect them, steal their ether wallet, whatever you want. So if that's the aim, it's all about users. So my objective in measuring is all about users too. What I want to do is actually measure the impact of invalid route filtering on users. And the real question that I'm trying to answer here is, if I create a bad route, a destination that's only available, only visible, when the route origination validation rules say, no, that's the wrong AS announcing that path. When that's the only way to get there, what proportion of users are steered there anyway? And if it's 0%, we've won. No more point, I'll shut up right now and we'll move on to questions. But, spoiler alert, it's certainly not 0%. There is a tangible proportion of users, a lot, who will still get directed to the destination when, according to route origination validation rules, ROV rules, it's not a good place to go. Now, like the V6 measurement, I think I'm got job security here for years, if not decades. This will take some time to actually get to whole of internet, I believe. Might be faster than V6, but it won't be instant. So I'd like to actually position this as a long-term measurement to see how we're going over the coming months and years. I think I've already mentioned it, but let me say it as well. ROV filtering, route origination validation filtering, is actually shorthand to, I've got time, using RPKI validation of published route origination attestations to detect and drop route objects that are invalid according to the conventional rower interpretation, which in practice means it's too specific, max length, or it's the wrong origin AS. So that's what I mean by ROV filtering. It's not that the cryptographic credentials are wrong, they're perfectly valid, but what they describe are an allowable set of routing objects, and what I'm seeing is something else. So that's what I mean by ROV filtering. And by filtering, what I mean is drop it. If you don't like what you see, don't depref it, drop it. So the methodology, to do this, then obviously I need to set up some bogus paths and set that up as the only route to a prefix to see who can go there. Secondly, I need to get a large collection of users from all over the internet and try and get them to reach a server that sits behind that route object. And to make sure that I understand what I'm seeing, I should use a control of a valid routing path that goes to the same destination. We'll see how I do that in a second. And then I just need to measure and compare, comparing good to bad, to see how many folk drop off when they can no longer get to a path because it's got bad credentials. Measure and compare. So the methodology. There are some amazingly good packages these days, and you don't need to use an RIR to set up your own RPKI repository. If you want to keep your secrets inside your domain, Krill is a really good package, and that's what we use to set this up as a delegated repository. It just worked. So good work, the folk at NLNet Labs, nice piece of work. By the way, as soon as you set one of these up, it's a bit like actually watching BGP. Everyone who's playing the game has to come and visit you to collect your objects. And they have to come all the time. So here's a graph of the number of unique visitors per day since we set this up in March of this year. And at the start, there are 800 different and distinct IP addresses. Now, I can't tell with IPv4 and IPv6 who's one and who's two. So there's at least 400 different folk. There might be 600. There might even be 800, but I doubt it. Looking at this. So today, 1,800 unique addresses. We've also had an issue in the standards world as whether rsync is any good or not. Stereo alert, it's not. And so what we've done over the last few years is actually devise a new synchronization protocol that uses HTTPS, RRDP, I think. Some will correct me in questions. And the red tracks the rsync visitors, the blue tracks the visitors that come over HTTPS. And as you can see, around about May, there was a big flip in some of this software, and all of a sudden, most of the world actually uses HTTP. But, you know, this is the internet. Old protocols never die. They just don't, they just linger on. The other thing I find about this, which is actually really curious, is that some folk only work weekdays in BGP security. Some folk only visit me Monday through Friday. It's the weekend, who cares what badness happens? I'm like, I find that bizarre, don't you? I'm like, we're meant to have automated systems. You're not running these things by hand, are you? Tell me you're not. Tell me you're not, because that would be really bad. So whatever you've got going in your cron tab, all I can say is don't forget Saturday and Sunday, because that's a weird variation. I have no explanation. Anyway, I've set up my RPKI repository. Great. Now I need to have good and bad. And what I thought was the easiest way to do this is to actually use time. And I flip between good and bad. So I've got my Krill controller, and this is the cron tab extract. And at these times, Monday, Friday, Monday, Thursday, or Monday, Thursday, Friday, I flip the rower to the good state. And at another set of times, I change the currently valid rower. I revoke the old one and issue a new one that puts it to a bad state. What does that cron tab actually look like? Well, we'll see in a second. Methodology again. Let me go a bit further. Sending a large number of users to one server is kind of silly these days. It's fragile. So Anycast, take that prefix and AS path. And don't forget, I never changed the advertisement. I only changed the rower. But take that fixed prefix and AS path and put it in a number of locations in the internet, preferably with different transit providers. The more the merrier. But the folk over at APNIC who pay my bills go, Jeff, don't be so crazy. And I'm going, but I need more. Don't be so crazy. How about 3? Yeah, grumble. So I've got 3 at the moment. I would certainly like more that actually offer this as part of an Anycast cloud. And all it does is just deliver a pixel block, a 1x1 block. It says, if you can get this, you've actually followed a route object, good or bad. The other thing too, the state of low cost virtual servers out there, there's many more of them in v4 than v6. And so this is almost forced by the issue of getting Anycast servers out there that speak BGP, a v4 only transit at this point in time. Love to get it into v6. Now, the test point. I've got my Anycast network, I've got my servers. Now I need to get a whole lot of people to try and go there. Well, I load this unique URL into a measurement script, and that uses a unique DNS component and HTTPS. So however the user tries to get that object, caching won't work. That's the intent of this. Unique label, HTTPS, come to me, hit me so I can see you. I feed this script into an advertising campaign. Thank you for Google for their support in paying some of those bills, because it really is appreciated. I feed that script into an advertising campaign, and I perform this test at a massive scale. Now, before I actually go into get what we found in that test, I should talk about this idea of good, bad flipping, because that's the way I'm doing control. It's good for a while, it's bad for a while. What does a while mean? How long should I keep a good state for everyone to learn that it's good? How long should I keep a bad state for everyone to now learn that what was good is now bad? Now, how long does it take for the routing system to know that this previously valid route is now invalid? And of course, how long does it take for that inverse transition? Now, interestingly, this is not a BGP problem anymore, because if you actually look at the propagation of BGP route objects and BGP withdrawals, the network is surprisingly dense. And the convergence times for state transitions in BGP tends to average around 70 seconds. And if you add some degree of transit delay, almost everyone knows what you're doing in BGP inside 2 minutes. But this is not BGP. This is determining what I do at my repository publication point. So I take what was good, it's got a certificate and it's got a published rower. I revoke that certificate, I revoke that rower, I publish a new rower with a new certificate. Great, but so what? I'm like, I'm in this dark room, I publish some new objects, gee, I'm good. Why isn't everyone listening? Hey, come down here. So what I really need to look at is the requery intervals for you lot, everyone else. All 1,800 unique IP addresses need to come and see that I've changed something. So how often do you come and visit me? Programmers, implementers should never be creative. Standards should be as comprehensive as possible, because if you don't specify something, if you leave it unspecified, everyone gets creative. Just look at gnats if you really want to see how lousy the world can be when you don't standardize how they behave. Gnats are as good an example as any. UDP and gnats, what a disaster. And oddly enough, we did it again here. How often should you look at the primary publication point in RPKI to see if things have changed? What does the standard say? Nothing. What should we do? Pick a number. Some folk have picked 2 minutes. Some folk have picked 10 minutes. Some folk have picked 1 hour. And even though there are these three timers that are pretty clear in the data, the same IP address comes to us in 2-minute intervals, 10-minute intervals, 1-hour intervals. There's also this sort of lag of a whole bunch of folk who come at all other times. And that's just sort of curious, because that's not a timer, that's something else. So I'll come back to the weird sort of noise in between the 3 peaks, but I've now, I think, got an answer about how long does it take for the world, those 1,800 folk who query me, or IP addresses, how long does it take for them to come back and see if anything's changed. Well, here's the cumulative distribution of that data. And what it says is within 2 hours, about 75% of those clients have seen the change. They've come back and visited me again within 2 hours of making a change. 2 hours, good enough. Why that lag? Why all the noise? I found this in Wikimedia, and what it says is it looks at the amount of time to complete a pass through the entire distributed RPKI repository set for a Wikimedia thing. And what it's doing is counting the amount of time it spends on each RPKI repository. And as you might see over here, there's a few folk that are really bad at publication, that it takes an awful long time to actually enter their site and grab down some details. And there are a number of changes too over time. So have a look at that URL at the bottom of the screen if you're at all interested in this. But the distributed system suffers from the performance of the individual repository publication points that introduces delays into that sweep. And so the system can't be arbitrarily fast. So now I've got enough to actually compile a schedule of good to bad. If I hold something good for at least 12 hours, the world will know it. The world will know it probably inside 10 hours of doing a test that I know is good. But just to be on the safe side, I've also used 36 hours. So the weekly schedule of good to bad is Sunday is bad, Mondays are good, Tuesdays are half good and half bad, Wednesdays are bad, Thursdays half good, half bad, Fridays all good, Saturdays good to bad. So that's the schedule of changes in my repository. And when I look to see that, and here's a view from stat.ripe.net, I see a bunch of activity that matches the point where I'm doing the changes. Because when I change from good to bad, the folk who are doing filtering withdraw it in BGP. And that withdrawal ripples around the net. Here is a pretty picture done by the amazing tool BGP Play that shows that when I do that state transition, everything goes harumph. It actually distorts a large amount of the routing mesh. Wonderful. I like eye candy. Here's a different view, which is probably more informative, where what I'm doing is actually looking at the fetch rate from all of those Anycast servers. And while it's a valid rower, almost everyone, 97, 98% of folk who, when given this URL, successfully fetch it. It's never 100%. Folk get bored, the ad stops, whatever. But as you see, when it's good, almost everyone's there. When I flip the rower state to bad and keep on measuring, then a lot fewer folk actually get that URL. So when it's bad, certainly there's some impact. And this is the same 7-day window that sort of shows what's going on in good to bad, bad to good, good to bad. There's more. Because when I blow this right up, and don't forget, BGP can propagate a change inside of 2 minutes to everywhere. But when I actually do the transition at my repository at second 0, right here, the fetch level remains about the same. There's a slight decline, but I'm still 95, 96% for 10 minutes, for 20 minutes, and just on 30 minutes, the last Anycast point disappears from view. And it seems that it's about 30 minutes to make a change in the repository to see the change reflected in BGP. Because in an Anycast system, when you turn off the lights, the light is still on until the last light is turned off. So oddly enough, this RPKI sensitivity is actually most dependent on the slowest people, the folk who are doing the 10-minute and potentially even the 1-hour requeries. It's the slowest people that determine its dynamic property, not the fastest. Being fast doesn't help. Bad to good. Well, interestingly, bad to good, the first light to pop up in Anycast says we're good. As further Anycast lights pop up, it's up. So what you actually find now is the transition's a lot faster, but it's still not that quick. It's still 5 minutes. And this seems to be the average between the 2-minute polling times and the 10-minute polling times. That on the whole, the transit folk with 2-minute retransmit time is eventually, see it and make their changes. It propagates where they're. So around 5 minutes for a bad to good to take effect, but much, much longer for good to bad. If this is all about DDoS, if this is all about filtering bad, if this is all about catching mistakes and fixing them, this graph is not as important as this one, because this is the sensitivity to remove a bad thing, to actually impose a rule that says drop that filter, drop that prefix, drop something. So 30 minutes is perhaps a more important timer than the bad to good timer. So there's a mix of 2, 10 and 60-minute sweep timers being used out there, but there are only 1,800 clients. What happens when every single network does this? When the number of clients jumps from 1,800 to 60,000, or in a couple of years, 100,000. That's an awful lot of sweeping. And for 100,000 folk to sweep across all these repositories all of the time, 2 minutes seems like a lot of thrashing. And I kind of wonder if this aggressive timer is too aggressive. On the other hand, 1 hour seems geological. Whatever mishap, whatever foobar, whatever you're trying to fix, 1 hour is kind of, wow, history. So I kind of like the 10-minute folk myself. I think it's a decent compromise. I think 2 is unsustainably fast. Despite the modern advances in computers, it still just seems too slow, too quick. I'd go 10 minutes myself. You might vary. We might even have a standard one day that actually says what the time should be. But until then, it's up to you. How well are we doing? Because when I put all that together and I look at the number of folk who can't get to a bad thing, since June of this year, when we started doing this measurement in earnest, it's been pretty steady. Around 17% of users can't get there. Now, V6 took 20 years to get to 17%. RPKI has taken months. So it's surprising, even DNSSEC took a long time. It's surprisingly rapid uptake. I was amazed when we turned this on that it was that prolific, that many users. And where are they? In July, there's a lot in Africa. Interesting. Some of the Scandies, brilliant. Australia, primordial. America, bits and pieces. Canada, frozen. That was July. This is October. I love these. Australia seems to have turned something on. South America, a little bit more. South Africa has changed. And, the Scandies are doing better. Oh, and Switzerland turned something on. Why? Well, it's not people turning on invalid route filtering everywhere. Some do. And we certainly know CCOM in South Africa. When I look at CCOM, 96%, perfect. It's as good as you get. AT&T Internet, 96%, perfect. It's as good as you get. But what if I'm a customer of AT&T? I don't have to do anything. If I learn all my routes from AT&T AS7018, then I'm covered. I can't get to bad route objects, because AT&T is doing the work for me. Now, in some ways, I actually don't need to do anything, because if the whole idea is to stop my users going to the bad place, then if my transits do it for me, done. Where's my beer? So in either case, the objective's achieved, but as long as a number of transits do this for you, then most of the user outcomes are actually attained with very little effort at all. So where do we go from this, and how do we get an even better picture? Well, the first thing is I'm using 3 points in the Anycast cloud and 3 transits. And I'm advertising basically a web server that serves 1-by-1 blocks. It's about as minimal as we get. More Anycar servers with more transit diversity would certainly help a lot in this effort. And if you can help me, particularly in different transits, drop me a line. I'd appreciate learning about this, because, you know, I do need more. 1,000 might be too many, but, you know, 100 would certainly be a lot better than 3. I'd actually like to understand the distinction between the folk who are riding on the back of transits who do it and the folk who are doing it. And one way of doing this is to actually do selective trace route, some kind of bombing trace route from the Anycar servers, to sort of thread in and find the point where the trace route stops. Now, what we're doing now is user impact, but I don't know who's actually doing the dropping. Selective trace route might expose that. But selective trace routes are messy. There's a lot of data and a lot of analysis, and as anyone has looked at trace route, it couldn't be worse. It really is peering through the fog, trying to understand where the, you know, obstacles are. Another way, a different fog, but more interesting perhaps, is looking at the point of valid to invalid and that route withdrawal. Because in ROV invalids, it's not a withdrawal at origin, it's a withdrawal of transit. And trying to find the propagation in terms of intermediate AS paths as BGP reconverges, you will find that in the new world, some ASs are no longer part of anybody's path. And so with enough digging around inside risks and route views, which are both immaculately neat tools for this, and looking at the updates that happen after withdrawal and the states of before and after. And don't forget, conveniently, there are, you know, 7 of these a week or 8 a week. It might be possible to actually find out the folk who are no longer there in transit by simply looking at BGP. But I call this next steps because I haven't done it yet, but it will be interesting. What else might we want to think about? Well, this exposes the issue that the big numbers we're getting are actually all about deployment in transits, not stubs. Does every stub need to deploy this? Are we really talking about the 6,000 or so ASs that are transits and the other 63 odd thousand or so who are merely stubs? If all the transits are doing filtering, why do the stubs need to do anything at all? If not, what's the minimal set? How could we protect most of the users with the sort of the minimal spanning set that stops bad actually propagating through BGP? And on the conversely, why should a stub network actually do this anyway? What's the benefit to the stub network of doing this kind of filtering? I don't have an instant answer. You might want to think about that. While we're at it, Telstra, there was an unfortunate episode a few weeks back where Telstra did a route leak. It looked to be some kind of iBGP to eBGP leak. But what they'd leaked were not their own routes, but they were tagged with their origin AS, but they were already described with rowers that positioned them somewhere else. And although Telstra AS1221 performs ingress filtering, it does not throw its announcements through the same filter. Should a stub, AS up, or even a transit filter their own announcements through the same filtering mechanisms as they filter the incoming announcements? And it sort of leads to this question, what's more important? Protecting everyone else from my fat fingers? Well, I think that's pretty important. Or protecting myself from your fat fingers? Ingress versus egress. But maybe we should think about that a little more, because the only routes, and Telstra leaked a few, not a lot, but a few, we only immediately saw the ones where there were rowers around. Where there was no rower, it wasn't clear whether it was a leak or not. And you sort of think, but how can I improve this situation while we've still only got partial deployment? And I think that leads to a line of thought about the prefix credentials we currently have and the AS credentials we don't. The IETF is still spending a lot of time thinking about inter-AS topology, But there's one other thing to look at, which if we take the example, and I'm sorry to pick on Telstra, but it just happened a few weeks ago, so convenient point. Were Telstra able, in a signed attestation, that they can update, every 2 hours, every hour if they want, every 2 minutes, an attestation that says, we originate these routes. Anything else we originate, you shouldn't believe. We are not that point. And this is a prefix versus AS attestation difference. The prefix holder is saying, I authorize this AS. But maybe the AS might want to say, this is everything I'm prepared to say. If you see anything else, either accidentally or deliberately, because accidents seem to be the primary target here. If I say anything else, help me out here, get rid of it. It's not what I meant. We might want to think about that and think about what AS tools, enumeration of all those originations, might actually help in this kind of situation. So, big questions to wrap up and fuel your thoughts for questions. As always, the question with security is once you get past the obsessive compulsion disorder of trying to secure everything and get to the point where you're trying to pragmatically spend some effort to make disruption difficult, not prevent it, difficult, then what are we trying to make difficult? To whom? Why? From what threat? What are we trying to protect here? Is it users? Is it the routing system? Is it our own fat fingers that are more of the problem? Or is it deliberate, well-resourced, and frankly hostile efforts to fool us via the routing system? What's the threat model? And unfortunately with routing, we've got no clear answer and a whole bunch of different motivations. You see, if it's a user protection issue, then route filtering is far more important for transits and exchanges. For stubs, the collateral damage is actually really quite low. But for transits, because all your customers get affected as well, then ROV filtering is way, way more important for transits. And of course, for exchanges. So if I was going to argue where the major incentives were, if you're a stub sitting off a number of transits and IXs, up to you. Don't forget, it might be a protection mechanism, but it's one more thing to go wrong. Okay, what about transits and exchanges? Lots of people are behind you at this point. It becomes more of an important issue to spend time and effort and spend the effort to make sure things don't go wrong. So maybe this is a tool for transits and exchanges, more for stubs. With that, I will leave you to ponder those questions, work hard at them, and if you've got any you want to ask right now, I'd be pleased to try and take them on. Thank you very much.
Thank you, Jeff. Excellent talk. We now have a few minutes for questions. Feel free to place them in the chat.
Well, it is a wonderful morning over here in Australia. I can guarantee that Thursday's a good day, okay? And no questions? Wow.
Right.
So here we are doing an awesomely important job, badly, and there are no questions. Okay. Is rsync bad? Let me say in one word, yes. Rsync was actually a pragmatic protocol that was just meant to do one thing. But oddly enough, when you uncover it, and there's a really good presentation, I think George Michelson may have done it at an IETF about 7 years ago, that looks at rsync. The answer is you didn't want to look there. And if you're looking at secure infrastructure, that's not a protocol you want to use. It is really bad. It's bad on security. It's possible to actually fool the checksums. There's a whole bunch of ways that rsync fails us. And if you are still running rsync, there's only one thing I can say, don't.
Any other questions?
There is the Q&A tab, don't forget, Jason.
from Gordon, right? Go ahead, Gordon.
Prognosis for path validation, asks Avi, and the prognosis is incredibly bad. The model that the IETF went and standardized, a full AS path validation with routers having keys, signing updates, etc., it's just only a security geek, only an OCD security geek would actually think this was viable. And more to the point too, it only solves the protocol problem, not the policy problem. So in some ways, it's never got deployed because it's never going to get deployed because it's a massive solution to an unknown problem. And is the problem worth solution? Probably not. There was a really nice idea that originally sort of came to air and got oxygen with a thing called SOBGP, Secure Origin BGP, around about maybe 20 years ago. Brian Weiss and Russ White at Cisco at the time were pushing it. It had a lot of good things and a lot of bad things. One of the good things was AS pairing. If I tell you all my partners, my peers, if you see a path that has me in it, then the adjacent ASs need to be in my attestations of partners or it's a fake. Nice idea. This was taken further in the IETF and the CIDR working group in recent months, years actually. Things go slowly, don't they? With ASPA, path attestations, but with a twist. You actually talk about your policy relationship. This is my provider. The beauty about that is that you now rely on what we call the no valley technique, that if someone's trying to synthesize a route, they've got to make sure that they preserve the no valley property of a route. All of this says, yes, you can lie in path with these adjacency attestation. Of course you can, but the degree of freedom to which you can lie gets more and more constrained. And so without the cost of signing over signing over signing over signing, AS path pairing actually gives you a decently efficient way of doing path validation without that overhead. Are we going to do it? Oh, God. I always think you get one shot. There is no IPv7. We just had one shot. And I think RPKI had one shot, and it didn't include path. And I think the effort to put path in is even greater than all the effort we've had so far. And that's sad.
And question for Gordon. Right.
Are those RPKI beacons still operating? If you look at the noisiest prefixes from the perspective of ROV operators, you'll find me. They're operating and they're operating permanently. I use them in a very particular way with very particular URIs. But if you just want to see whether you can see those prefixes, any BGP amateur can see them, or if you send me a mail, I'll actually tell you the prefix and the AS, and you too can watch them go up and down.
A question from John Kieran. Any ideas on how to prove the 30-minute long lag from valid to invalid?
I think all of rsync with that 1 hour has got to go. I think the 2-minute is too aggressive. I think the 10-minute sweeps are a starting point, but that Wikimedia plot there, if you look hard, and the slide doesn't show you enough, but I did give you the URL, there are a couple, Taiwan, there are a couple of RPKI repository points that most clients, including Wikimedias, are taking an awfully long time to sweep through, up to 27 minutes. If we can make those distributed repository points faster, and if you are making your own, if you are rolling krill, good idea, don't use a Raspberry Pi. Use something with grunt, real grunt. Put it in big infrastructure. Allow it to go fast. If you do that, plus get rid of the 1 hour sweep timers, we can get folk down to 10 minutes and get the response time inside 15 rather than 30. Faster than that, I don't think it'll scale, John. So maybe 15 minutes is about as good as we're going to get. Is 30 minutes good enough? Well, I'm not sure. I think so. I think we can do a bit better. But if you're looking for seconds, different universe. This won't work.
One quick question from Tony Tower. Occurs to me there's a diversity risk of the delegated publication point is affected by the ROA and you make a mistake. How to better improve the diversity of publication points?
Oh, Tony, you've walked right into it. What's the best reliable flooding algorithm we've ever invented? The answer is BGP. The answer is not RRDP. If we really want to flood these information objects all over the BGP speaking world, then as everyone else has found, BGP kitchen sink, the one answer is BGP. Don't use route objects, invent a new object and use the fact these days that BGP message sizes are now up to 65K long and flood the network using the BGP protocol to sync up all the repository data points. This idea that we can make a second flooding protocol called RRDP and somehow, by wishful thinking rather than protocol engineering, to be perfectly frank, somehow we can make that distributed system become a reliable flooding system to all the caches. Nah, there's no magic. Sorry, it ain't going to work. So if we really want to make it better, throw it inside an engineered flooding protocol algorithm like BGP and stop mucking around with silly algorithms on the side. Was that an opinion? Yes, it was.
Good. Thank you. Thank you, Jeff.